All right, folks, if you could come in and grab your seats. This is the room for Inside the Cube, a guided tour of Kubernetes cluster setup. I'm James. I'm going to be the track captain for this. So a few items before I turn it over to Liz. One is if you have a phone, please make sure to mute it. We don't want anyone getting interrupted while they're on these workshops. So go ahead and do that now. This is going to be a workshop slot, so it's going to be a little longer. It's actually going to go all the way through to lunch, so until 12:30. So this is an hour-and-a-half slot. One final note, because this is a workshop, we want you all to have a great time. We're going to actually have TAs for this. So if everyone who signed up to be a TA could stand up and wave your hand, just be really visible. So these are the people you can ask for help. You can ask me for help too. We'd all be happy to help you with it. So don't hesitate to ask. You can raise your hand to get attention, or you can ask in the Slack room. If you're not on the Slack, it should have been in some of the emails that you got pre-conference. There's a USENIX SREcon Slack.
I've got a slide for it as well.
Perfect. Great. All right. So I'm going to turn it over to Liz for this awesome presentation on Kubernetes. So Liz, take it away.
All right, everybody, thank you very much for coming. Before I move away from this slide, I've said this once, but if you've just filed in, this workshop is going to assume that you have a Ubuntu VM somewhere. So pick a cloud provider, pick a hypervisor, VirtualBox, whatever. You need a Ubuntu VM somewhere if you want to follow along. If you don't want to follow along, then get out your phone, because we've got some long tutorial parts that are probably not going to be all that interesting. And so without any further ado, this is Kubernetes from a cake mix, and I will explain to you what exactly that means in just a second. Before I get into that, we have a Slack for this conference. If you're not already on the Slack, you should join up, because myself will be in there, the TAs will be in there. We will all be trying to answer your questions as best as possible. But also, if you see somebody next to you who is having trouble, please give them a hand. If you notice, there are probably a lot of you in here and about 4 TAs, so we have our hands full. So everybody help your neighbors out. The channel is Kube201, I think, something like that. K8, the digit 8S_201 is the channel name. My name is Liz Frost. My Twitter handle is still in beta. It's also in the bottom corner of all of my slides. It's mostly just pictures of dogs. So if that's the sort of thing you're into, then that's probably a good Twitter account to follow. I am on the Kate Slack. Kubernetes has its own Slack. It's very large. If you need Kubernetes help, that is where you can find me. Personally, I am a queer, trans, and polyamorous woman. I am a dog mom. I created the pony that you see in the background of all of my slides. Her name is kubecuddle, and that's how you pronounce the command, in my opinion. Kubectl is kubecuddle. And most importantly, why should you actually listen to me? I am a SIG cluster lifecycle member, which possibly doesn't mean anything to you, but lifecycle is setting up clusters and tearing down clusters, which is what we're going to be doing today. A lot of the commands we're going to be run are going to be based on code that I helped write. I have a lot of code in Kubernetes, especially some of the components we're going to be using today. And one of those components is kubeadm. This is a list of the owners. And you can see that I'm not just a approver, but I'm a reviewer. So I have checked a lot of the code that went into here as well. But I think what we really need to answer right now is, what is Kubernetes? I'm pretty sure half the presentations at SREcon this year have a slide that answers a question something like this. What is Kubernetes? Now, there's a lot of ways you can explain it. This is a diagram from the Kubernetes website itself. It shows you taking a lot of squares, putting them into a circle, and then you get squares inside of a circle. Here is an architecture diagram. You can see there's masters and some unfortunate terminology. This looks very good, but unfortunately, this is actually the Mesos architecture. This isn't Kubernetes at all, but you probably wouldn't have noticed if I hadn't told you. This is a architecture diagram that you would probably see. You can see that there's a Kubernetes logo in a cloud, which sounds very good. It seems like it's probably a good idea, but like, what is actually in there? We don't know. So this is what people are probably talking about when they talk about Kubernetes. So there is a Kubernetes API, and the user, in theory at least, shouldn't care about what's on the other side of the API. That API defines the way you interact with Kubernetes. And this is, in fact, a kind of a legal definition. So there are a set of conformance tests, and you run those conformance tests against an API, and you back that API with whatever you want. And if all of the conformance tests passed, congratulations, you are now certified Kubernetes. And anything you want can be behind that. Amazon EKS could be certified. Google Cloud could be certified. The Rust backend that I'm always threatening to write for Kubernetes could be certified. A wizard did it, could be certified. As long as it passes all of the tests, it's Kubernetes. That's basically what it means. But that isn't a very good basis for a talk. Like, I could just sit up here and run the conformance tests, but they take about an hour, and it's watching really slow tests run. It's not very interesting. So, and because there is such a large constellation of ways that you could be potentially setting Kubernetes up, we need to have some opinions. And one of the tools that we use for this is something called kubeadm. And now here you can see where the name of my talk comes from. I don't want to make Kubernetes from scratch. I don't want to make every single decision that I need to get Kubernetes up and running, because I don't have all the information I need to make all of those decisions. And we're going to use a tool called kubeadm, which has a lot of opinions, but lets us ignore those opinions if we so desire. And so that's what we're going to do. We're going to walk through some of the choices it makes, some of the ways that it does things, and in some cases, we're going to take its advice, think about it very carefully, and then just completely ignore it and do something completely different. So if you want a very short version of this talk, if you just run sudo kubeadm init in a container, probably it will set up a Kubernetes master for you. So if you just want to run that command and then go to lunch early, that's probably how you would do that. But we're here to learn what actually goes on behind those scenes. So if I do kubeadm --help, this is the list of all of the commands that it is going to run individually. Don't try to take a picture of this slide. I can collapse some of them. So if I get rid of the certificates and if I get rid of all of the kubeconfig files, it gets a little bit more manageable. I take away the description text, and it almost looks like a reasonable amount of text to put on a slide. This is the rough outline that we're going to follow for this talk. I've chosen kubeadm as a sort of guided tour to work you through setting up a Kubernetes cluster, because it has a lot of opinions about the way these things should work. We're not going to do these all completely in order, and we're not going to do all of these steps, because while they're all necessary for a complete, secure, production-ready cluster, we're not making a complete, secure, production-ready cluster. We're just making a cluster. So we can take a couple of shortcuts. What are we actually going to set up? So these are the 5 components that we are going to try to get running on our virtual machines. We have the kubelet, we have etcd, we have API server, we have controller manager, and we have scheduler. Don't worry if you don't know what most of those things mean. Hopefully by the end of this talk, you will. So if you look at the Kubernetes cloud, inside that is, in a lot of cases, something that looks kind of like this. You can see the dotted lines represent processes, the dashed lines represent containers, and we have a whole bunch of HTTP that is running between them. You can see the API server is kind of in the middle of everything. There's Docker, but it isn't communicating with anything else. But this is really only one way to look at what's going on. This sort of depicts information flow. How does information flow from one component to another component? But if you want to talk about control flow, what components control other components, you can rearrange this diagram a little bit. So in this sense, kubelet is at the top of everything because kubelet is the component that is going to say, hey, Docker, run all of these containers. I want all of these containers to be running. And while I call them containers, they are actually going to just be Kubernetes pods. And those Kubernetes pods are going to be run by the kubelet, but that makes the kubelet kind of the ideal place for us to start. If you look at this thing, you can see, well, nothing particularly, the kubelet doesn't depend on anything. And everything else seems to depend on the kubelet, so why don't we get started with that? The kubelet itself is pretty much just a wrapper around Docker that knows how to speak the Kubernetes API. It doesn't have to be Docker. There are other container runtimes that are supported, but I would say 9 times out of 10, if you are running Kubernetes, you're probably running Docker containers. And so these are the components that we need to get our kubelet running properly. We need the kubelet. We need kubeadm because kubeadm is going to sort of help us along through this process. And we need Docker itself running. But wait a second. The kubelet connects to the API server so that I can get pods. But the API server is being run by the kubelet. We can't, that's not going to work. So we have to break this loop somehow. And the way we break that loop is using static manifests. This is a visual pun because it's static. So basically, the way that this process works is we start static pods. We try to connect to the API server. And if we don't, we go back to the beginning. We try to start those pods again. The interesting thing about this is that if the kubelet itself crashes, the containers themselves keep running. So we can just kind of crash loop forever trying to connect to the API server. But for this first step, we're not going to try to connect to the API server at all. We're just going to start a couple of static pods, and that's going to be it. One of the nice things about the kubelet is that it's actually a perfectly usable sort of half-baked Kubernetes cluster itself. If all you need are pods, you don't want services, you don't want deployments, you don't want any of those other things that Kubernetes provides for you, you can kind of just get away with starting to use the kubelet by itself. And that is going to be your first task. You are going to, your mission, should you choose to accept it, is that you are going to go to your Ubuntu machine, you're going to install the kubelet, you're going to install kubeadm, and you're going to install Docker, and you are going to try to get one static pod working. The instructions are all on this bit.ly link. There's a Git repository. If you need help, please raise your hand or come find one of the TAs. We would all love to help, but let's get cracking.
If you have an empty seat next to you, so that people who are standing in the back can come sit down and get on the laptop. Plenty of space, so you can come sit down.
If we, thank you. If you are downloading a box, it may be a little too late for that at this point. Other people do need to connect to their instances. So if you have the option, I highly recommend doing this through some kind of cloud provider, AWS, GCP, whatever. It'll make the lives of everyone around you much easier than trying to download like an ISO at this point.
I have some ISOs. So if you've got a flash drive, I can come and give you one. Did any of the companies give out flash drives as swag this year?
Raise your hand if you have a working virtual machine running somewhere. Do you have a working virtual machine running somewhere? Okay. Raise your hand if you have finished tutorial 1. Okay, people are still working, it sounds. Great. Raise your hand if you need help. And I think I saw a couple of things. First of all, if you are running a virtual machine and it is too old, cat etc lsb release, if you're running a VM that's too old, you will not be able to get Kubernetes installed. Any other?
So something else, if you're finding yourself stuck, don't feel like you have to do all these steps yourself. Look to your neighbor. Maybe you can pair together on this. Perfectly reasonable. So as a reminder, if you do need help, you can just raise your hand really high so we can see it, and we'll come on over. But if you aren't able to get this working and you just want to follow along and watch, Liz is working on getting that projected right now. So got an instance provisioning to kind of walk through some of the steps.
There we go. Thought I had that. Need to copy this for that one person, and then I should be.
have mounted an RW open 12. That's working at least. So.
Anything I can do to help out with the audience, or?
.io install step got added, there wasn't an apt update step before that, so people are now not updating.
I added it.
Okay,
Yep.
it's fixed.
I fixed. Yeah, we fixed
Great.
it.
Also, if we could double the font size on the terminal at least.
Yeah. Oh, yes.
Hey, so we're actually live updating the GitHub repo steps. So if you're failing to find Docker, we had to add an apt-get update step previously to the Docker command. So give that a try if that's not working for you.
Hey, raise your hand if you've got a working virtual machine. Hey, that's a lot better than before. Raise your hand if you think you've got a good handle on tutorial 1. Not quite so many hands. I'm going to run through it on stage because we certainly didn't get everyone. And I finally got my virtual machine to work because I'm using the same Wi-Fi as everybody else. So if my friendly AV tech in the back could turn on my Lavo mic in a couple seconds. All right. So I have my kubelet right here, and it is crash looping, which is not the state you really want anything to be in. So, but it is what it is supposed to be doing right now. So we're going to fix that. If I look at the last couple lines of the journal, says that there's no kubelet configuration file, so I guess we're going to need one of those. First thing we need to do is we need to make a configuration file. So let's open that file. We'll just put this somewhere temporary for now. Now, this is basically how you know that you're working with Kubernetes, because you're going to see a kind and an API version at the top of every single one of your files. Pretty much every one of these things is usually in beta or alpha or something like that. The kubelet configuration is actually relatively new. It prevents you from needing to pass in hundreds of arguments like you're going to have to for every other step of this process. So we've got what kind of looks like a kubeconfig file working. So let's copy it into the right place. And let's see where we're crashing now. Now we're crashing because we don't have a bootstrap kubelet. The bootstrap file is actually not what we want. That's obscuring the error that we don't have a way to connect to the API server. And by default, when we don't have a way to connect to the API server, we fall back on trying to get our bootstrap config. But we want to configure this in complete standalone mode. So what we're going to do instead is just tell the kubelet that it shouldn't worry about the API server at all. So we will go into systemd and just kind of change this stuff in the bleeding heart of the kubelet. Yeah, I wouldn't worry about that anymore. Now because we changed something in systemd, we need to reload the daemon. And we can just restart the kubelet. Yeah, thank you. I wrote this really long tutorial so I wouldn't have to do any live coding. Joke's on me. All right, let's see how it's doing now. We are still grumpy. Let's see what it's grumpy about now. no client provided, cannot use webhook authentication. I think this is the next step of our tutorial. Right, we need to disable authentication because we're not worried about authentication right now. This is I'm the only one who can access this machine, and we're just going to pretend that everything is fine. So let's edit that configuration file that we applied earlier. var lib kubelet config.yaml. And we are going to set anonymous to, right now, the default is anonymous is disabled and the webhook is enabled. So instead, we are going to be just a little bit more permissive. Webhooks are disabled because those require the API server. Anonymous is enabled because that's what we are, anonymous. And authorization is separate from authentication. Anonymous authentication basically means I have confirmed that I'm anonymous. But if you don't allow every anonymous user to do things, then it doesn't really matter that you've done that. So let's see if this makes our kubelet just a little bit happier. Yeah, let's give it a restart. Sometimes that's not necessary, but often it is. Please disable swap. Sudo swap off -a. Let's restart it again. That looks a little happier. Let's see what our status is. Yay! All right, we've got a kubelet running. Now, let's make one of those pods that I've been talking about. So we're going to set the static pod path in this configuration file. So the static pod path is literally just going to be a directory full of YAML, and everything that goes into that directory, the kubelet is going to try its very best to run. And I'm going to pick the path that kubeadm would pick if I was using kubeadm to set all of this up. So /etc Kubernetes manifests. And we'll give this a restart again. All right. It appears to not be crashing again, which is really the best we can hope for at this point. I am going to come up with this really not terribly interesting pod. And I'm just going to cat that directly into simple pod.yaml. So let's copy this pod that I put in my tutorial, which is just an example pod that has a really basic web service in it. And let's see, has everything crashed yet? Nothing's crashed. Let's look at Docker. All of these things are actually going to be running inside of Docker, which means even though we don't have an API server to check if the pod is running, we can do this to see if our container is running. And it looks like so far it's not. But my app pod is. So what I suspect is happening right now is that it is trying to download this brand new pod over the network. So this might take a second. But I can tell that it is in fact picking it up, because if I look at the logs, nope, still no container. All right, cool, thank you. Thank you very much all for being the beta test audience for this tutorial. I know that probably it was rude to subject you to a user test without asking you beforehand, but just pretend that we're an A/B test for a modern web company. There's an A group somewhere else in this building who has really good internet, and we're going to see who has better ad metrics. I am curious why there's 2 of these. Huh. I don't know what that means. All right, well, while we're waiting for this to finish, I think probably the best thing for me to do right now is to move on with my slide deck. And if we're lucky, by the time I get to the next slides, we'll be done with this. And if memory serves, this next tutorial after this one doesn't require the internet. So if you've made it this far, you shouldn't have too much trouble. So this is going to be our introduction to kubeadm. Kubeadm is a component that I have worked on that is supposed to be the easy installer for the Kubernetes experience. So the first thing that it does is it's going to take us through a whole bunch of pre-flight checks that are intended to be sort of like guardrails for getting your Kubernetes set up. We're going to avoid a bunch of common problems and make sure that your environment is like a reasonable place to install Kubernetes. Obviously, we can't check everything, and we only check these things once. So if they fail, then if they fail later on, there's not much we can do about that. But for now, the next tutorial is just try to get all of the pre-flight checks to pass. And that's what we're gonna take a crack at right now. Did this work? No, it didn't. Whatever. So if I do sudo kubeadm init phase pre-flight, it should give me a whole bunch of errors that I can work with. Yep, I don't have enough CPUs. The port is already in use, and I'm using the wrong kind of Docker. So the cgroupfs is, I think, related to snap. Docker is not enabled. That one's an easy one to fix. It gives me a command that I can use to fix it. Enable docker.service. Oh yeah, I absolutely need sudo. And I am going to real quick restart this VM and add an extra CPU. And hope that maybe restarting it will fix some of the other problems that I'm dealing with. tether my phone. It was my pill thing.
Raise your hand if you're having trouble connecting to the internet. We have someone here on site looking at it now. One person, okay. Sounds like we have the internet under control now.
I'm tethering, Liz. I'm sure I can send my phone bill to USENIX. Hey, there we go. All right, well, I got this container running. It's not returning the things I want to, but the fact that it's returning error message is really just about as good as the actual message that I wanted it to return. And I have, well, all of the pre-flight messages that I care about. The port 10250 basically just means that I'm already running a kubelet, because at this point, The kubeadm installer inspects that you have kubelet installed but not running, but it doesn't matter that it's already in use. So let's go back to the slides real quick, and I'm going to teach you something that you might not actually know. So the next step in getting our Kubernetes cluster running is etcd. Etcd on their website has a bunch of marketing copy about things that etcd does really well. It uses Raft, which nobody understands. It uses automatic TLS. It can write 10,000 writes per second. I don't even know if that's a lot, if I'm honest with you. But what you care about is that it is a key value store. And for our purposes, it is optionally distributed, which means I can just run one image, which is what exactly what I'm going to do. And for Kubernetes, it is the only part of all of the Kubernetes infrastructure that we're going to be looking at today that is stateful, which means it's a pretty important thing to get right. We can't start the API server until we have somewhere to store all of its data. And there are a whole bunch of client certificates that you need for it, which is one of the reasons we're using kubeadm. If you ever want to talk to somebody about certificates in Kubernetes, I wrote almost all of the code for dealing with certificates inside of kubeadm, and I could complain for weeks about it. So where do we put it? If you were running a high availability etcd, you can use an externally hosted etcd. You could probably have a whole bunch of different etcd instances. But since we aren't going to do about that, we don't care about that, we are going to use what's called self-hosted etcd, which means we are going to run etcd inside a pod, inside our kubelet, and then we're just going to allow our API server to connect to it. We're also, as I mentioned before, only going to use one single node because it's a real pain to get replication working properly, and we don't need it right now. It's not going to show us anything. So this is the basic step that the next tutorial is going to follow. First off, you're going to generate a whole bunch of certificates. You're going to create the manifest for etcd, and then we're going to run a health check to make sure that we've actually got it set up working properly. So take a look at tutorial 3. If you have completed tutorial 1 at this point, tutorial 3 should be pretty easy. If you haven't completed tutorial 1 at this point, in just a couple seconds, I will be running through tutorial 3 myself. And I will, because at this point, if you haven't gotten tutorial 1 yet, you probably aren't going to. However, all of these tutorials are open source. They're all on GitHub. And I would welcome any questions you have in GitHub issues for the repository. So once you go home and you have better Wi-Fi, you can try running through this. And hopefully you'll have a little bit more luck. So tutorial 3. Tutorial 3 is all about etcd. So the first thing that we need to do is generate us some certificates. First off, etcd has its own CA. Kubernetes has a couple CAs that we care about, but etcd has its own because if you have access to SED, you have access to basically all of Kubernetes. There are no access controls on etcd. So we're going to make our new CA, sudo kubeadm init phase certs etcd CA. And we have our new certificate. It lives in OpenSSL. There's our certificate. There's not a lot going on here. Our common name is etcdca, and other than being a CA, There's not anything particularly special about it. Now, since the server is going to serve over HTTPS, we're going to generate its certificate as well. And we can use OpenSSL to verify that this is actually signed by the server. Hey, it's signed. All that code I wrote wasn't for nothing after all. So now we're going to make our manifest. So this is a pod. API version is just v1 because the core API is special and doesn't have a slash or anything like that. Kind, pod. This is probably everybody's first Kubernetes object that they create. You create a lot of pods when you're doing tutorials, and when you're actually running Kubernetes in production, you basically never create them. So let's just copy a little bit of metadata, and we're all going to collectively hope that the etcd image that we're going to download isn't that big, because otherwise it will never succeed. In fact, what I'm going to do is, while I'm working on this, I am going to download it in the background. All right, we're downloading that right now. All right, got an etcd layer. We need to be able to connect to the cluster. Normally, you would use a service for this, but the kubelet can't run services. The kubelet can only run pods. And because of that, we're going to cheat a little bit. We're just going to literally tell Docker to wire this up to the host network. So I just say host network is true. And that means when we expose when we expose on localhost, we're going to expose on localhost for not just the pod we're running, but for the entire machine that we're setting up. Now, we need to set up some volumes. Now, you make volumes in two parts for Kubernetes. The first thing we want is we need to actually define the volumes that we want. Obviously, pods aren't stateful, but etcd is quite stateful, so we need to mount a file structure so that in between pod restarts, we have access to etcd. And in addition to that, we need to mount those certificates that we just made. Because remember, we made those certificates inside of our node, and our pod won't have access to them unless we explicitly grant that access. But by default, we've created these volumes. We're not doing anything with them right now. We need to go in and specify that we actually want to use these volumes. So let's mount them. We're going to mount them in exactly the same space where we mounted them from, just so we don't get confused about which path is which. But in theory, you could mount these wherever you wanted. And sometimes that's a really powerful technique. All right. Remember how I warned you about how everything has a ton of arguments? In the tutorial, I go through what every single one of these arguments does. But we are running quite short on time, so I'm literally just going to copy-paste them. If you look at the tutorial, you can see the documentation associated with every single one of these commands. There's a good reason why I picked all of them. If you were using something like kubeadm, it would pick them all out for you, and it would pick a lot more than these. But I've chosen the bare minimum that I think I need to get everything working. So let's write this out and see what happens. There's our etcd daemon, and it doesn't appear to be crashing, which is pretty cool. So let's generate some certificates to actually access it. So what we're going to do is sudo kubeadm init phase certs etcd health check client. And this is used for exactly this in production Kubernetes. Oh, spelled something wrong. Health, yeah, there we go. And now, this one should also be signed by that CA. Okay, and now if I just curl our local host, I'm going to have to provide a whole bunch of arguments for all those certificates, but our node is healthy. That's pretty cool. So we've got working etcd now. Unfortunately, we don't have a lot of time left, so I'm probably just going to have to speed through the rest of the tutorials. I'm very sorry to everybody who came and didn't have working Wi-Fi or any of that stuff. If I give this workshop again, your suffering will not go in vain, and we will have a whole bunch of flash drives and clouds, and it's going to be great. But let's go back to the slide deck for just a second. Because the next thing is the API server. And the API server is actually sort of the brains of the operation, even though it tries not to actually do much for itself. So I like to think of the API server as the glue that holds everything together. It's the only thing that's allowed to talk to etcd because it's where all of the authentication lives, but most of the actual processes carried on by Kubernetes aren't done by the API server itself. It's really just responsible for validating requests and storing objects. So a lot of APIs are actually written inside of API server, as you might expect, but that's not necessarily the case. So if you create an API group, you can see here, this is deployments. This is a very common thing to work with. We have an API group. Remember I told you core was special? That's because it doesn't have an API group. But then we have a version, a namespace, a resource, and a resource name. And this is basically the way API server sees the world. Pretty much every single, excuse me, sorry. Pretty much every single URL in Kubernetes is going to look something like this. And this is how an API object that isn't resident in the API server would work. So the API server is going to furnish the actual, hey, I want to see this, I want this object to be in etcd. But once it gets there, the API server isn't going to have anything to do with it. Instead, it's going to send out a notification to everything that is watching for those objects to say, hey, I got a new one of these. And then that controller is the thing that's actually responsible for making changes based on that. But this isn't the only thing it can do. If you run kubectl exec something, you can't connect directly to the kubelet because the kubelet is on a private network. So the Kube API server actually acts as a bastion between these two things So you send a command to the API server. The API server forwards it to a running pod. It gets output, and it forwards that output back to you. This is tutorial 4. This is where we actually get our API server up and running. This is normally a little bit of an involved thing, but there's a cheat, which is that if you just look at the YAML I paste at the very end, that's basically all you need to do. So I'm going to just zoom through that real quick and get our whole YAML up and running. First thing, we need to generate some certificates. Remember I said before, etcd has its own CA, and that's because if the regular CA was the same as the etcd CA, then every certificate that was valid for accessing Kubernetes in any way would also be valid for accessing etcd. And remember, I said etcd doesn't have any access control. That probably wouldn't be a very good thing to do. So we're going to make a new CA. And we're going to make an API server certificate. It's signed with a whole bunch of different things. We're not going to worry too much about that right now. The other thing we need are service accounts. Service accounts are accounts that are associated with internal Kubernetes functions. You can request that your application be assigned a service account, but they are never associated with an actual user, and so we generate them a little bit differently. They're basically just signed by a private key that the controller that manages service accounts knows about. So let's generate these real fast. Init phase certs SA. And if I cat the public key, you can see it's literally just a public RSA key. So, and we're also going to need to connect to etcd. Now this one's interesting. So this one is signed, despite not being in the etcd directory. This one is signed by the etcd CA, even though we're using it for the API server. You can see here, if I try to validate it against the API server CA, it's not going to work. That's good. Now, we're just going to spit out a whole bunch of YAML. Once again, this is documented in a lot of detail in the tutorial, but unfortunately, we're out of time. So I am just going to paste it in. Oh, that didn't work. And of course, it's going to take a second for that actually to pull down from the network. Let's give it a little helping hand. Yeah. So this will be up in just a second. Oh, there it is. I'm not going to generate the rest of the things. Unfortunately, I am basically completely out of time. So I am going to give you the rest of my slides. The next thing we would have done is we would have set up the controller manager. Controller manager is weird because those words basically don't mean anything in the industry. A manager manages something, a controller controls something. If you called it the manager controller, it would probably have the exact same semantic meaning. So this is basically what a controller does in the Kubernetes world. It takes in a whole bunch of state changes using that watch mechanism I talked about earlier, and it takes in the desired state. It loops over it, compares those two, and takes some action as a result of that. Here's an example. The replica set controller has a list of replica sets. It knows every replica set that's been created, and it knows when they're destroyed. It also gets events about, hey, this pod isn't available anymore, or hey, this pod has already been created. And in response to those events, it creates or destroys pods, again, by just posting back to the API server. The node controller does something similar. There is a separate component of Kubernetes that sets the status of health for an individual node. And this component looks at those health statuses, and it looks at the list of pods. And if it sees a whole bunch of containers that are scheduled on nodes that aren't healthy anymore, it'll destroy those pods, and it'll put them somewhere else. Now, there are a whole bunch of controllers, but for simplicity's sake and for operational ease, they're all compiled into one binary and run as one pod. So you can think of them sort of as like, we have a machine, and then we have a pod, and inside the pod, we have a container, and inside the container, we have all of these little Go routines. So it's basically turtles all the way down. That is the tutorial where we would have set that up. And then the scheduler. The scheduler is basically a special case of controllers. It takes in pods, it takes in a list of nodes, and it assigns those two things together. Sometimes this is a pretty easy job, but nodes and pods can both specify a whole bunch of things that the scheduler has to care about. All of these things are things the scheduler has to take into account. And then there are some things that are just like preferences. A pod can also say, I really want this to be true, but I'd rather be scheduled than not at all. So there are some soft limits, and there are some hard limits, and there are some limits that only apply when the pod is created. The scheduler is responsible for doing something called bin packing, which basically means I've got a whole bunch of containers. They all use certain resources, and I've got to fit them in wherever they fit. And now, this is where you would have set up the scheduler. And if we had had a whole bunch of extra time, there are a whole bunch of extra things that we could have done. The DNS, the container networking, proxying, all of these things are basically required for your cluster to be useful and not just a fun demonstration project. But we don't. So here's what your cluster isn't. The cluster that you would have built is not secure, it's not production ready, it's not resilient, it's not high availability, and it certainly isn't going to get that certified Kubernetes logo anytime soon. But what it is yours. So I hope that you all were not too terribly frustrated. Please head home, carry out the tutorials, ask for me for help on Twitter. I'll stay in the SREcon Slack. I will take issues on GitHub. And thank you all so very much for coming.